Okay, we're going to cover something called percent yield today. So what that is based on two types of ways you look at your products, and the theoretical yield and the actual yield. So the theoretical yield is the amount of product that you're expecting to make based on a calculation. So that would be the answer you get from a T-chart. So if you put a certain amount in, how much you're going to get out. The actual yield is the amount of product that is actually made when running an experiment. So when you actually do it in a lab, how much you get. So this in a problem will always be given. You're not going to be actually doing a lab for every period, type of problem like this to figure out the actual. So they'll say someone did the experiment and they actually got this amount from the reaction. So percent yield is comparing the two, the actual yield to the theoretical yield. So you would take the actual yield, what you got in the laboratory setting, and divide it by what you thought you were going to get based on your calculation, the theoretical yield. And to make that a percent, because this will be like a decimal number, you'd multiply this by 100. So let's say you were at a factory, car factory, and they, based on their usual outcomes, they are hoping to make 150 cars in 1 week. This particular week, they made 135 cars actually made. So this is the actual. This is that they calculated from previous weeks that they theoretically usually make 150. So what you would do here is take 135 divided by 150, multiply by 100, and you get 90%. Okay, so to apply this to an actual chemistry type of one, here they're saying what percent yield of sodium chloride here if you start with 4.6 moles of calcium chloride and you actually made 8.5 moles of sodium chloride. So this is the actual. We're going to use this reactant here, and we want to figure out how many moles of sodium chloride we can make from this calcium chloride reactant. So the reactant that you get, you're going to pop into your T-chart. So 4.6 mole of calcium chloride. We want to figure out moles of sodium chloride to match the actual yield. So this is what we're going to be figuring out, the theoretical yield here. I'm going to put mole of calcium chloride on the bottom to cancel out the one on the top. And I'm going to transition to mole of what I'm looking for, sodium chloride. So I see that I have 3 moles calcium chloride on the bottom and 1 mole or 6 moles sodium chloride on top. So if I do 4.6 times 6 divided by 3, you get 9.2 moles. So you thought you were going to make 9.2 moles of sodium chloride. You actually made 8.5. So using the equation here, we're going to do the actual divided by theoretical. So we actually made 8.5 moles. We thought we were going to make 9.2 moles times 100, and you get 92.4%. Okay, so let's try a different problem. Let's try this one here. What's the percent yield of calcium nitride? You have 2.5 moles of calcium chloride. That's your reactant. Actual yield of product is 116 grams of calcium nitride. Okay, so we want to put this reactant, 2.5 mole calcium chloride, and convert that to grams of calcium nitride. Okay, so mole calcium chloride on the bottom to cancel out the one on the top. I have 3 moles calcium chloride. I'm going to go to mole of calcium nitride, and that is 1 mole. Now I'm going to go from mole to mass here. So 1 mole of calcium nitride and the grams of it. When you calculate the molar mass of this, you would get 148. So when you separate out the elements. So your answer here would be 123 grams. That's your theoretical yield. You thought you were going to make that amount. So we're going to take 116 actual yield grams divided by the 123 grams that we thought we were going to make times 100, and you get 94.3% as your answer. Okay.